second option for solving an exponential equation is to, again, use a logarithm, but oddly enough, we don't have to necessarily match the base of the exponential. So, for example, this is the same equation we used in the previous video. And what we saw is that, yes, we did use a logarithm base 5, but by the time we got to the end, if we wanted to get a decimal value of it, we needed to use the change of base formula to put it in the calculator. So we needed either the common logarithm or the natural logarithm. Well, why not just start with them then? Because there is another property of logarithms, the power property of logarithms, that says if we have the logarithm with any base of an exponential expression, and note that the base of the exponential does not match the base of the logarithm here, that the exponent can be brought down in front as if it were a coefficient. And that's really what we end up needing here. Is the problem is, how do we get x by itself when it's up there in the exponent? This would give us a way to bring the x out of the exponent. So we can use, again, either the common logarithm or the natural logarithm. Genuinely, we can use any base we want, but since we would need base 10 or base e to go into the calculator anyway, we might as well just start with one of those. So I used common logarithm in the previous video. This time I will use the natural logarithm. And again, redo it on both sides of the equation. Now, there's not much we can do with that. I suppose we could put it in the calculator right at this point, but I'm going to choose not to. What we can do now, though, is use that power property of logarithms I just showed you to bring that x down in front and make it a coefficient. Now, at this point, we need to remember that the natural log of 5 is a constant value. If we were to put that in the calculator, we would get a single value, and no matter how many times you put it in the calculator, we would get the same value. There are no variables in this piece right here, so this is a constant. And the way we undo multiplication by a constant is to divide by that constant. Of course, we need to divide on both sides then. But what we arrive at is the same format we would have had if we had used a logarithm base 5 as in the first video, but now we don't need the change of base formula. It's kind of already built into what we're doing here. Now, this doesn't make this method necessarily better or worse. Same with the previous method, but it's a matter of which property you're most comfortable with. This method of using either the natural or common logarithm to begin with requires you to be comfortable with the power property of logarithms, which, to be fair, is probably the most commonly used of all of the logarithmic properties. So it tends to be one that most people are comfortable and familiar with. To do it the previous way requires us to know the change of base formula, which is still very useful and definitely has its place. But I find that the power property of logarithms is more commonly remembered and better remembered. So in my experience, most people will choose to use this method, but you use what works for you.